Yeah, good morning one and all. So in the last class we have discussed about S matrix and the properties of S matrix. Okay, so and E plane T. So what is S matrix? So to know the power relations, in a microwave network, so we are using the S matrix. So it is a two-port network. S matrix is a two-port network. So port means a pair of terminals. So in the input side we are having two terminals, in the output side and we are having two terminals. So the pair of terminals is called port. So that's why S matrix is a two-port network. So if you see the properties of S matrix, so these are the properties of S matrix. So it satisfies symmetry property. So that is Sij equal to, you can write Sji. It satisfies unitary property and zero property. Okay. So these are some of the properties of S matrix. And we have discussed the E plane T. So E plane T means here. So E plane T is formed by attaching a simple waveguide to the broader dimension of a rectangular waveguide. So it has two ports. It has three ports and two arms. So port 1 and port 2 are called collinear arms and port 3 is called side arm. Okay. So substitute the properties of S matrix, then we'll find out the E plane T S matrix, right? So today, so we discuss about H plane T junction. So what is H plane T? How it form? What is H plane T? See here, H plane T junction is formed by cutting a rectangular slot along the width of the main waveguide. See here, H plane T is formed by cutting a rectangular slot along the width of the main waveguide and attaching another waveguide. So the side arms are called H arm. The side arms are called H arm. So see the difference between E plane T and H plane T. See here, see the difference between E plane T and H plane T. In E plane T, the waveguide is attached along the broader dimension of the rectangular waveguide, right? Okay. In H plane T, so it is formed by cutting a rectangular slot along the width of the waveguide, right? So along the, see here. So it is a rectangular waveguide. So here we are attaching another waveguide along the width of this main waveguide. Okay? Okay, this waveguide is attached to this waveguide. So along the width of the waveguide, along the width of the main waveguide. So it is the main waveguide, it is the secondary waveguide, right? Here the secondary waveguide is attached along the width of the main waveguide, that is in the H plane T. Okay? See here, it is a port 3. So these are the port 1 and port 2. So here there are three possible ports, so that the scattering matrix is a 3 by 3 scattering matrix. Here we are having three ports, right? So H plane T junction is formed by cutting a rectangular slot along the width of the main waveguide. Okay, along the width of the main waveguide and attaching another waveguide. So the side arms are called H arms. So side arms are called H arms. Okay. So there are three possible ports, so that the scattering matrix is 3 by 3 scattering matrix. So we have S11, S12, S13, S21, S22, S23, S31, S32, S33. Okay. So we know about symmetry property. So using the symmetry property, so we can write S12 equal to S21, S13 equal to S31, and S23 equal to S32. So using the symmetry property, right? So if the port is perfectly matched, we can write S33 equal to 0. If the port is perfectly matched, we can write S33 equal to 0. So due to the plane of symmetry of the junction, we can write S13 equal to S23. But in the E plane T, so here S13 equal to minus S23, that is in the E plane T. But in the H plane T, S13 equal to S23, because here there is no phase shift. Okay, there is no phase shift at port 1 and port 2. But in the E plane T, we have the phase shift between two ports, port 1 and port 2. So the outputs at port 1 and port 2 are having the 180 degrees phase shift, that is in the E plane T. But in the H plane T, we don't have any phase shift. The output contains at the port 1 and port 2. Okay. So due to the plane of symmetry of the junction, we can write S13 equal to S23. So with these properties, so the S matrix becomes, so substitute all these properties. So that is S12 equal to S21, S13 equal to S31, S23 equal to S32, and S13 equal to S23, and S33 equal to 0. So substitute all these properties in equation 1. Then we have S11, S12, S13 in place of S21. We can write S12, and it is S22 in the place of S23. Okay, so S23, as it is S23, and in the place of S31 we can write S13. Okay, in the place of S23, see here, in the place of S23 we can write S13. Due to perfectly matched, S33 becomes 0. S33 becomes 0, right? So that is due to perfectly matched port. So from the unity property, we can write S into X complex conjugate equal to I. This we can write, so S11, S12, S13, S12, S22, S23, S13, S13, 0. See here, so from the unity property, we can write like this. Here multiply R1 C1, here multiply R1 C1. Then you will get S11 into complex conjugate of S11 plus S12 into complex conjugate of S12 plus S13 into complex conjugate of S13 equal to 1, right? So if you multiply R1 C1, so first row, first column. So from this we can write S11 square plus S12 square plus S13 square equal to 1. Okay. In the second case, multiply R2 C2. The procedure is same. So as in the E plane T, here multiply R2 C2. Then you will get S12, S12, so S12 square plus S22 square plus S23 square equal to 1. S23 square equal to 1, right? So in place of S23, you can write S13. Okay. So in place of S23, we can write S13. So this equation becomes S12 square plus S22 square plus S13 square equal to 1. The third case, multiplying R3C3. So if you multiply R3C3, then you will get S13 into complex conjugate of S13 plus S23 into complex conjugate of S23 plus 0 equal to 1. Okay. So from this we get S13 square. So from here we get S13 square plus S23 square equal to 1. Okay. So in place of S23, we can write S13. So 2 S13 square equal to 1. So it becomes 2 S13 square equal to 1. Why? Because so here in the place of S23, we can write S13. Okay. So from this S13 square equal to 1 by 2. S13 square equal to 1 by 2. So if you compare equation 3 and 4, see here. So compare equations 3 and 4. So this equation, that is S11 square plus S12 square plus S13 square, and the fourth equation is S12 square plus S22 square plus S13 square equal to 1. Okay. So from these two equations we can write, so this one, it is the third equation and it is the fourth equation. So from this we can write S11 equal to S22, right? S11 equal to S22. So for you here it is S12 square, S12 square and S13 square and S13 square, right? If you compare these two equations, so we can write S11 equal to S22. And multiplying R3C1. Multiplying R3C1. So from this multiplying R3C1, then you will get S13 S11 star, that is complex conjugate of S11 plus S13 into complex conjugate of S12 equal to 0. Okay. So if you multiply R3C1, then you will get S13 into complex conjugate of S11 plus S13 into complex conjugate of S12 equal to 0. So from this we can write S11 complex conjugate of S11, okay, S11 star plus S12 star equal to 0. Why? Because S13 not equal to 0. So from the previous equation, see here, so what is S13? So S13 equal to 1 by root 2, right? So that's why S13 not equal to 0. Then this S11 plus S12 becomes 0. Okay. So from this we can write S11 equal to minus S12. So from this we can write S11 equal to minus S12. Okay. So substitute this equation 9. S13. So in equation 3, what is equation 3? So this one, S11 square plus S12 square plus S13 square equal to 1. Okay. So then you will get S11 square plus S11 square plus 1 by 2 equal to 1. So from this we get S11 square equal to 1 by 4, right? So and S11 equal to 1 by 2. S11 equal to 1 by 2. and S12 equal to minus 1 by 2. So from equation 7 you can write S11 equal to S22 equal to 1 by 2. So substitute all these values, that is S11, S12, S21, S22 and so on. So substitute all these values in the S matrix, then you will get this one 1 by 2 minus 1 by 2, 1 by root 2 minus 1 by 2 minus 1 by 2, 1 by root 2, 1 by root 2, 1 by root 2, 0. Okay, clear? So if you substitute all the values in the S matrix, then you will get this one, right? So here, so B equal to S into A. So from this, so we get B1, B2, B3 equal to this one S matrix equation. So S matrix and A1, A2, A3. So then the B1 equation will be B1 equal to A1 by 2. So minus A2 by 2 plus A2 by root 2. So that is the B1. Next B2 equal to minus A1 by 2 plus A2 by 2 plus A3 by root 2. Next B3 equal to, so A1 by root 2, A1 by root 2, A2 by root 2 plus 0. Okay. So these are the B1, B2, B3 equations. So here in the first case substitute A1 equal to 0, comma A2 equal to 0 and A3 not equal to 0. Okay. So substitute A1, A2 equal to 0 and A3 not equal to 0 in the B1 equation. Then you will get B1 equal to A3 by root 2. A3 by root 2. So it is A3, not A2. So it is A1 by 2 minus A2 by 2 plus A3 by root 2, right? So if you multiply these two, then we get B1 equal to A1 by 2 minus A2 by 2 plus A3 by root 2, right? So here if you substitute A1 equal to 0 and A2 equal to 0, then you will get B1 equal to A3 by root 2 and B2 equal to 1 by root 2 A3. B2 equal to 1 by root 2 A3 and B3 equal to 0, right? So in B3 substitute A1 equal to A2 equal to 0, then it becomes 0. Okay. So that is about B1, B2. See here, there is no sign, there is no opposite sign between B1 and B2. Here these two are equal, B1 equal to B2, right? So then we can say that the P3 is the power input at port 3. At port 3, P3 is the input power. Then the power divides equally between port 1 and port 2. Okay. So at port 3, the power is entered into port 3. This power divides equally between port 1 and port 2 with the same sign, right? With the same phase, But in E plane T, we have the phase shift 180 degrees. So that's why there we got B1 equal to, so 1 by root 2 A3 and B2 equal to minus 1 by root 2 A3. But here we are getting B1 equal to B2. In the second case, so apply A1 equal to A2 equal to A and A3 equal to 0. So in the second case, apply A1 equal to A2 equal to A and A3 equal to 0. So then we get B1 equal to 0, comma B2 equal to 0 and B3 equal to root 2 A. In the third case, So apply A2, A3 equal to 0 and A1 not equal to 0. Okay. So then we get B1 equal to A1 by 2, B2 equal to minus A1 by 2, and B3 equal to A1 by root 2. Here we are substituting different possible combinations. So in these equations, right? So that is about H plane T. So that is about H plane T. Okay. So next we will see magic T. Magic T. So see the diagram of magic T. In the magic T, the rectangular slots are cut both along the width and breadth of the waveguide, and side arms are attached. Okay. So that means it is the combination of both E plane T and H plane T. It is a combination of both E plane T and H plane T. So here the magic T is formed. The rectangular slots are cut both along the width and breadth of a waveguide. Okay, width and breadth of a waveguide. Width and breadth of a waveguide. Here we are attaching the two waveguides along the width and along the breadth of a waveguide. We are attaching the two waveguides along the width and along the breadth of a waveguide. Okay. Here all ports are matched. It has the advantage. It has the advantage. So in this, all ports are matched. So it has 4 ports: port 1, port 2, port 3 and port 4. It has 4 ports. Magic T has 4 ports. Okay. So that's why the S matrix is a 4 by 4 S matrix. So it is S11, S12, S13, S14. So similarly S21, S22, S23, S24, S31, S32, S33, S34, S41, S42, S43, S44. It is a 4 by 4 S matrix. Since magic T has 4 ports, okay. So here these ports are called H. It is a H arm and this one is the E arm. So due to the plane of symmetry of the junction, so because of H plane T, we can write S23 equal to S13, right? So from the H plane T, we can write S23 equal to S13. Okay. So because of E plane T, we can write S24 equal to minus S14. Because of E plane T, we can write S24 equal to minus S14. But because of H plane T, we can write S23 equal to S13. Okay. And here all the ports are matched. So if all the ports are perfectly matched, then we can write S33 equal to S44 equal to 0. S33 and S44 equal to 0. And from the symmetry property, we can write S12 equal to S21, S13 equal to S31, S14 equal to S41, S23 equal to S32, S34 equal to S43 and S24 equal to S42. So this is due to symmetry property. See here, because of geometry of the junction, an input at port 3 cannot come out of port 4, since these are isolated ports. Here port 3 and port 4 are isolated ports. Okay, see here, port 3 and port 4. See here, these two ports. Okay, port 3 and port 4 are isolated ports. That means if you apply the input at port 3, if you apply the input at port 3. So isolation means, so it cannot come out of port 4. It cannot come out of port 4, right? So these two are the isolated ports. So that's why we can write S34 equal to S43 equal to 0. So third and fourth ports. So third port and fourth ports are the isolated ports. Okay? So if you apply input at port 3, it cannot come out of port 4. So then we can write S34 equal to S43 equal to 0. Okay? So these are the isolated ports, port 3 and port 4. So and substitute all these properties in equation 1. So substitute all these properties in equation 1, then you will get.
Good morning, sir.
This is the S matrix. So S equal to S11, S12, S13, S14. Okay? S12, S22, S13. So minus S14. S13, S13, 0, 0. So S14 minus S14, 0, 0, right? Okay. So from the unity property, we can write this one. So it is a 4 by 4 matrix, right? So from this, multiply R1 C1, then we get S11 square plus S12 square plus S13 square plus S14 square equal to 1. Right? So multiply row 1, column 1. Next, multiply R2 C2. Multiply R2 C2. So we will get S12 square plus S22 square plus S13 square plus S24 square. Okay? And multiply R3 C3. Multiply R3 C3. So we get 2 S13 square equal to 1. So from this S13 equal to 1 by root 2. And multiply R4 C4. R4 C4. Okay. So from this we get 2 into S14 square equal to 1. So and S14 equal to 1 by root 2. So here S13 equal to S14, that is equal to 1 by root 2. And multiply R4 C1. And multiply R4 C1. Then you will get S14 complex conjugate of S11 minus S12 S14 equal to 0. Okay. So first multiply R1 C1, next multiply R2 C2, next multiply R3 C3, next multiply R4 C4, and finally multiply R4 C1. Okay. So then S11 equal to S12. So next, so substitute. So 4, 5, 6 equations in equation 1. Then you get S11 square plus S11 square plus 1 by 2 plus 1 by 2 equal to 1. So then you will get 2 S11 square equal to 0. So from this we can write S11 equal to 0, right? So compare. So equation 2 and 4, we get S11 equal to S22. S11 equal to S22. Okay. Here port 1 and port 2 are perfectly matched to the junction. So if S11 equal to S22 equal to 0, this means, it means here port 1 and port 2 are perfectly matched. Okay, are perfectly matched. So that's why S11 equal to S22 equal to 0. So and substitute all these values in equation 1. So then you will get this S matrix. Finally, so we get this S matrix. S equal to 0, 0, 1 by root 2, 1 by root 2, 0, 0, 1 by root 2 minus 1 by root 2. So again 1 by root 2, 1 by root 2, 0, 0, 1 by root 2 minus 1 by root 2, 0, 0, right? Here the 4 ports are perfectly matched. Here, see here, S11, S22 equal to 0. So similarly S33, S44 equal to 0. Right? So all the 4 ports are perfectly matched to the junction. So it is called a magic T. So in the magic T, 4 ports are perfectly matched. So that's why it is called magic T. Right? So then, so take B equal to S into A. The B1 equation will be 1 by root 2 A3 plus A4 by root 2, and B2 equation will be 1 by root 2 A3 minus A4 by root 2, and the B3 equation is 1 by root 2 A1 plus 1 by root 2 A2, and B4 equation is A1 by root 2 minus A2 by root 2. So these 4 equations coming from this matrix form, right? So in this, in the first case, substitute A1, A2, A4 equal to 0 and A3 not equal to 0. In the first case, substitute A1, A2, A4 equal to 0 and A3 not equal to 0. Then you will get B1 equal to A3 by root 2, B2 equal to A3 by root 2, and B3, B4 equal to 0. Okay? So and substitute the remaining cases also. So case 2, case 3. So if you substitute in the case 2, if you substitute A4 equal to 0, A3 equal to 0, A2 equal to 0 and A1 not equal to 0, then we get B1 equal to 0, B2 0, B3 A1 by root 2 and B4 A1 by root 2. Okay? So in case 3, if you substitute A1, A3, A4 equal to 0 and A2 not equal to 0, so you get B1 equal to 0, B2 equal to 0, B3 equal to A2 by root 2 and B4 equal to minus A2 by root 2. Okay? So like that we can substitute different combinations. So it is about magic T. So magic T is nothing but it is a combination of both E plane T and H plane T. Okay? So this is about H plane T and magic T, the S parameters, S matrix of H plane T and magic T. So with this I am going to stop the presentation. If you have any doubts, you can ask me.